Please, Amit Patil,
Yes,
please introduce our expert.
yes.
This is our first lecture, and I also inform that one lecture from Dr. K.K. Goyal on innovation and prospects of MSMEs in the agriculture sector of India. It is postponed because his parents are very serious, and he requested me to kindly allow him to leave today's session, his session. And I think in future we will try to conduct his lecture. So please, Engineer Amit Patil, for formal introduction of KP Niranjan, Dr. Niranjan Prasad ji.
Thank you, sir. A very good afternoon to all of you. Today, I welcome you all into this IGFRI Diamond Jubilee Online Lecture Series 2022 on entrepreneurship development in processing, fodder, and allied crops. This lecture series is being organized by Agribusiness Incubation Center, ICAR, Indian Grassland and Fodder Research Institute, Jhansi, in collaboration with Indian Society of Agricultural Engineers, New Delhi, and Range Management Society of India, Jhansi. So under this lecture series, up to now, 8 lectures have been delivered, and that lectures covered variety of topics like entrepreneurship development in processing, fodder and allied crops, uh, prospects of bamboo shoot processing, value addition, and emerging startups, community-led rangeland revival and management in CPR setups, hydroponics and aeroponics, a new vista in agripreneurship, current status of agro-food robotics and artificial intelligence, prospect entrepreneurship from rural urban waste and business model canvas and financing innovation issues and opportunities, entrepreneurship and agroforestry for timber production. So in this, all these lectures have been uploaded on our YouTube channel. So we will provide the link of our YouTube channel. From there, you can access all these lectures easily. So this is the time for lecture 9 and 10. But because of Dr. K.K. Goyal, due to his father and mother's severe sickness condition, he could not able to join today. So we will start this lecture 10 on entrepreneurship potential and opportunities in natural resins and gums for starters. And this lecture 10 will be delivered by Dr. Niranjan Prasad sir, principal scientist and head MPE division and project coordinator. AINP on harvesting, processing, and value addition of natural resins and gums. ICAR Indian Institute of Natural Resins and Gums, Karachi. So before moving ahead, I would like to give some brief about Dr. Niranjan Prasad sir. Dr. Prasad, born in 1966 in Patna, did his Bachelor's of Engineering in Agricultural Engineering from CTAE Udaipur in 1988 and Masters of Technology in Food Processing in 1991, PhD from IIT Kharagpur in 1996. He obtained his postdoctoral training in smart active packaging from Michigan State University, USA. He worked as lecturer in Narist, Arunachal Pradesh during 1996 to 97. Later on, he joined Indian Lake Research Institute, Ranchi as Agricultural Research Service Scientist in 1997 and presently working as Principal Scientist and Head of Mechanization and Process Engineering Division. He is also working as Project Coordinator of All India Network Project on Harvesting, Processing and Value Addition for Natural Resins and Gums. During his 20 years of experience in research and extension, he has published many research articles in national and international journals. he has developed a number of tools and machines for leg cultivation and processing, like tree pruner, leg scraper, and leg processing unit, which have been commercialized. Dr. Prasad is a recipient of number of awards like ICAI, Indian Society of Agri Engineers, Jain Irrigation Award, DST, ACRC Visiting Fellowship, ISAE Distinguished Service Certificate, Commendation Medal, Bayved Allahabad Fellowship, and Fellow of ISAE and David Foundation Award. So thank you, sir, for joining us today and accepting our invitation for delivering this wonderful lecture. So I invite Dr. Niranjan Prasad, sir, for delivering his lecture. Sir, you can share your screen.
Thank you. It is coming host disabled participant screen sharing. Please allow me to share my screen.
Yes, sir. Allowed. Now you can share, sir. Please share. Yeah, sir. Your screen is visible.
I think screen is visible and my sound is audible.
Yes, sir.
Thank you very much. Today I will be presenting a lecture on entrepreneurship potential and opportunities in natural resins and gums startups. I would like to thank in the beginning itself Director IGFRI Jhansi for giving me opportunity to deliver this lecture, and the organizer of this lecture series, Dr. P.K. Pathak. In the beginning, I welcome all the person attending this lecture, all the dignitaries attending this lecture, and as informed by organizer, this lecture is being organized by IGFRI on the occasion of Golden Jubilee of the institute. So on behalf of Indian Institute of Natural Resins and Gums and All India Network Project on Harvesting, Processing and Value Addition of Natural Resins and Gums, I welcome all the participants who are attending this lecture. I would like to cover regarding production, processing, value addition and entrepreneurship opportunities in gum and resin sector in our country as well as abroad. So let us know some basic details about this sector. India is a rich center of biodiversity and over 45,000 plant species, including 120 gums and resin yielding plants are there in our country. And Indonesia, India and China are the largest producer of natural resins and gums. And it is a multi-billion dollar global industry. And as far as India is concerned, we are leader in production of guar gum, karaya gum and lac. If we see the sources of natural resins and gums, there are different sources from which we get natural resins and gums. It could be seed of plants or trees, or directly sometime natural resins and gums are coming as a exudate, or it may be coming from seaweeds, or sometimes microorganisms are also utilized to make gums and resins. And insect also produces resin. So if we see in the category of seed gum, guar gum, tamarind gum, cassia tora gum, psyllium gum, these are the gums which we get from seed. As far as exudate gums are concerned, we are getting this from Acacia senegal tree, the gum arabic, gum karaya, gum ghatti, babul gum. These are exudate gums we are getting from tree directly as a exudate, or we can say secretion. Then as far as resins are concerned, we are getting uh, resin from plant like Pinus roxburghi or sal tree, we are getting damar. And as far as gums and resins are concerned, we are getting as a Google, Salai, and Esa foetida from plant as a exudate. Even seed gums, even seaweeds are source of gum, like agar, carignan. These are some of gums which we get from seaweeds. Even microorganism produces gum, and in that category, xanthum gum, jalan gum are important ones. And an interesting resin which is secreted by insect, that is lac, we get from some host tree on which lac insects are settling, like kusum, palas, and berry trees, and then lac insect is producing as a secretion from its body as lac resin. So these are some of the sources which could uh, be the source for production of natural resins and gums in nature. Then let us know about what are differences between resins, gums, and gum resins. So resins are solid or semi-solid material, usually a complex mixture of organic compounds called terpenes, which are insoluble in water but soluble in certain organic solvents. Uh, Under natural resins category, lac is one which is coming from insects, and then rosin, copal, damar, etc. are resins which are coming from a plant source. We can see uh, the pine resin coming out from the pine tree, and when it is coming from pine tree, it contains turpentine also. That is why it is in liquid form. And once a turpentine oil is removed, then we get the resin part like this, as we can see in the photograph. So next category is gums. Major difference between gums and resins is that gums are either soluble in water or it disperses in water, and it is a polymeric material that can be dissolved in or dispersed in water to give thickening and gelling agent. And examples of gums are, as we have seen earlier, guar gum, karaya gum, gum arabic, xanthum gum. These are some of the gums, and its a source, as we have seen earlier, either it may be directly secreted from the tree, or it may come from plant seeds, or may be produced by microbes or seaweeds. Then there is another interesting third category that is known as gum resin. It is a natural mixture of gums and resins in variable proportion. Therefore, it possesses properties of both gums and resins, and they contain traces of essential oil and are partly soluble in water, as it contains some part as a gum, and they have a penetrating and characteristics odor and taste. And examples of gum resin are Asafoetida, Mayer, Kugel, and Olivanum, mainly coming from the plant source. In the photograph, we can see from Google tree how these gum resins are produced and utilized for different applications. In this slide, we will see the different applications of these natural resins and gums. As far as resins are concerned, these are used in paint, varnishes, lacquer, cosmetic, adhesive, medicine, and food industries. And gums are mainly used in food industry as a thickening agent, gelling agent, stabilizer, and emulsifier. It is also used in textile industries, pharmaceutical industries, and cosmetic industries. As far as gum resins are concerned, it is used in perfumery industry, cosmetic industry, medicine, spices, and incense. If we look into this particular slide, we can know the potential of entrepreneurship development in gum and resin sectors, as it has applications in wide range of industries varying from food, pharmaceuticals, and cosmetic and whatnot. Then now coming to some of the natural resins and gums produced in India, we will see what is the production scenario of natural resins and gums production in India. So if we see, uh, if we are taking together all the resins, its production annually is approximately 55.5 thousand metric ton. And as far as gums are concerned, we are producing more than 2 lakh tons of gum every year, and major portion is coming from guar gum. As far as gum resins are concerned, India is producing about 1500 metric ton of gum. So altogether, if we see, we are producing annually about 2.8 lakh tons of natural resins and gums annually. So this, from this we can have idea about the potential of this sector in terms of input. Then if we see in detail the production of resins in India, major production is coming from as a lac and rosin, and lac production is mainly taking place in states of Jharkhand, Chhattisgarh, Madhya Pradesh, and West Bengal. As far as rosins are concerned, as we know that these are produced from uh, pinus group of trees. So these trees are mainly in hills, and that is why major production is taking place in Uttaranchal, Himachal Pradesh, Punjab, NEH region, and damar, which is mainly coming from sal tree and some other trees also, which we are producing in states of West Bengal, Assam, Jharkhand, and Kerala. And some other resins, which is produced about 8,000 ton, is coming from Maharashtra, Madhya Pradesh, and Gujarat. So this is scenario about production of natural resins in India. Then coming to gums, which is a major fraction in natural resins and gum production. So here at the topmost position is guar gum. Uh, Annually we are producing more than 2 lakh tons of guar gum, and mainly production is coming from states of Rajasthan, Gujarat, Haryana, and Uttar Pradesh. As far as gum karaya is concerned, in which India is leader, its production is around 1,500 metric ton, mainly coming from states of Madhya Pradesh, Odisha, Andhra Pradesh, and Chhattisgarh. Then there is another important gum resin, that is Asafoetida. Though we are not producing much, but this particular commodity we are importing from other countries like Afghanistan, Iran, and processing of Asafoetida is being done in our country, and then again it is being re-exported. So that figure will appear in import-export data, what I will be presenting in coming slides. Then in small quantity, we are also producing gum arabic, which is mainly coming from Acacia senegal tree, which are in abundant number in Rajasthan, Madhya Pradesh, and Gujarat. And there are some other important natural resins gums like gum ghatti, Asian gum. We are producing around 1500 metric ton, mainly coming from states of Madhya Pradesh, Chhattisgarh and Maharashtra. So now let us know something about the natural resins and gums export and import from India. So if we see the scenario of natural resins, we see here that maximum export we are doing from India is of lakh around 7,000 metric ton annually, and this is a figure of 2019 and 20. And at the same time, we are importing in large quantity resin like gum rosin and damar vattu. So if we see the total export or import figure, actually we are importing more quantity of resin in comparison to what we are exporting from our country. Now coming to total gum export and import during 2019-20. Here we see that under exudate gum category, we are mainly exporting Asian gum, that is mainly gum ghatti, then gum arabic and gum karaya in major quantity. At the same time, we are importing large quantity of gum arabic mainly from African countries like Sudan uh, to meet our internal consumption. As we know that this gum arabic is used in different food items, even in pharmaceuticals and other industries. So to meet our internal demand, we are required to import large quantity of gum arabic. Even scenario of gum karaya is not good. Earlier we used to export large quantity of gum karaya, but due to internal demand, we have now started importing from African countries gum karaya also. So here if we see the total export import figure, again we are importing more quantity of exudate gums from other countries compared with the quantity we are exporting. Then now coming to seed gums, under this category, we are exporting a large quantity of guar gum in pulverized powder form, and even cassia tora gum we are exporting in substantial quantity, apart from psyllium gum and the tamarind kernel powder. So here we are in a very good condition in terms of earning foreign exchange from natural resins and gums, or we can say seed gum. And as far as gum resins is concerned, as I told earlier, that we are importing a large quantity of Essa foetida from other countries, and then we are processing it and re-exporting it. So here also, if we see overall, the more quantity of natural resins and gum resin we are importing compared with the uh, figure of export from our country.
ये एक्सटर्नल कुछ प्रॉब्लम्स क्यों हो रही है अमित?
Yes, sir. Sir,
कुछ
I don't know how this has come,
actually, sir,
but I am also observing these lines coming.
yeah, अभिषेक पटेल है, उसने सर ये किया, मैंने उसको रिमूव कर दिया, but how it
ठीक है.
will go, I don't know.
Okay, I don't know how people do like that. ठीक है. Okay, sir.
Should I reload it?
No sir, आप कंटिन्यू चलिए.
Okay, okay. So if we see the total export and import figure, so annually we can see we are exporting more than 2.8 lakh metric ton of gums and resins, and from that we are earning more than 3,300 crores
Amit,
of rupees
sir,
annually
excuse
from
me,
the export.
Dr. Niranjan, Amit,
Yes.
Yes, sir.
डॉक्टर निरंजन प्रसाद को रिलोड करना पड़ेगा क्या?
आई थिंक सर, हाँ सर, एक बार कर दीजिए क्योंकि
कर दीजिए
हाँ
सर।
सर, हो नहीं रहा।
So I am stopping the sharing and reloading it.
Yes, sir.
Is it
Okay.
is it all right?
Yeah, sir.
Okay, sir.
Okay.
Friends, this is not good thing that such type of matter you are doing. This is good information for entrepreneurship development in the area of gums, resins, and lab. And I think very good information is given by Dr. Niranjan Prasad. Okay, sir.
So I have loaded it again, and now I think the problem is solved. So if we see the overall scenario of export of energy compared with other agricultural commodities, so for last about 10 years we can see the share of energy in agri export is about 3.7%, and uh, on an average we can see, though this is a higher figure due to large quantity of export and its value in 3 years, that is from 2011 to 2014. So on an average, energy export was of the tune of say 8,000 crores of rupees in last 10 years. And if we see the its share in total export of our country, it is on an average for last 10 years 0.46%. So this gives a rough picture of importance of this sector and potential in entrepreneurship development. Now, let us know some benefits of this sector. So we can say categorize in two types of benefits, that is direct benefit and indirect benefit. So under direct benefit from gum or resin production, there is additional income to the farmers mainly residing in forest and sub-forest area, in coastal areas, in deserts, in which these natural resins and gums are produced. And another important thing is when the weather condition is dry, when rainfall is less, when there is a drought, production of natural resins and gums is more. When under such a situation other crops fail, there is a bumper harvest for natural resins and gums. So this is a plus point for this sector, and it becomes a livelihood support in those difficult times for the people. And mostly the harvest season for natural resins and gums are in summer season, when farmers do not have much summer crop in their field, so they have some free time in which they can utilize his time in collecting natural resins and gums, or producing natural resins and gums, which can give them secondary livelihood option. And then if primary processing of natural resins and gums produced are done at a village level, from that primary processed products, they can get a better return from their produce. And at the same time, the industry for which the produce in form of natural resins and gums they are getting, will be of a better quality, and they will require a lesser time in processing, and they will be in a position to produce better value-added products. And uh, in the rural areas, in as we explained earlier, that when there is a drought condition, production of natural resins and gums is more, so it gives in employment opportunity in those difficult times for people living in the gum producing areas. If we see indirect benefit of natural resins and gums, this may appear very obvious, that when we are taking natural resins and gums, in other words, we can say we are safeguarding those trees uh, from deforestation, and that is how it is helping us in afforestation of the forest areas, or where the deforestation has taken place. We can plant more natural resins and gums, which can help in even climate change mitigation. It will also help in carbon fixation. At the same time, dry branches, leaves, etc., which falls from these trees can become a source of firewood for cooking in rural areas. So these are some of the indirect benefit coming from this gum and resin sector. Then there is a scope of promoting natural resins and gums trees on farmlands, and introduction of this resins and gum yielding trees in agroforestry model we can have, and some of the agroforestry model have been developed by IGFRI Jhansi Institute, and those are being popularized so that natural resins and gum yielding trees are introduced in agroforestry system, and those who are adopting this are benefited by additional income. Then even on the land which is not utilized for any other purpose, or even in forest area where deforestation has taken place, there we can introduce gum and resin yielding trees, or we can even plant these trees on field boundaries, so that it gives additional income to the growers. Then coming to natural gum yielding trees and scope of raising plantation. So there are different gum trees which can give good amount of gum, and there are states in our country which are climatically suitable for introducing plantation of these trees. If we consider Acacia Senegal, we can have its plantation in Rajasthan, Gujarat, Uttar Pradesh, and Madhya Pradesh, and particularly in Rajasthan, it can also help in spread of desert further, and at the same time, it can give a good amount of gums for livelihood support of the people. Acacia nilotica is another tree which produces gum, and we already see that it is in large number in Chhattisgarh, and there is further scope of introducing this tree for gum production, as well as for timber production also. Then there is another important gum tree, that is Anagaceous latifolia. This can also be introduced in Madhya Pradesh, Chhattisgarh, and Jharkhand. Likewise, Sterculia urens, Butea monosperma, then Bucania lengens. These can also be introduced in different states where forest covers are there, and it can uh, give people living in forest and sub-forest area as an additional source of income. Then this is give the estimated income by introducing plantation of these natural resins and gums. Uh, so we can see here that in terms of per hectare annually, uh, it can give right from 20,000 to 50,000 per hectare per year. If we introduce these trees in the land which is vacant or not utilized for any other purpose or remains barren land. At the same time, these gum trees can be introduced on boundaries, field boundaries, and in one of the model at Kafri, Jhansi, Acacia Senegal have been planted on the boundaries, and it not only gives gum, but it acts as a fence also for the field boundaries. And if we plant, we can have another source of livelihood from these trees after say 5 to 10 years uh, in terms of the additional income they get from gum produced from these trees. Then coming to some important regions of India, uh, lac is one of the resin which is produced by lac insect, which settle on the branches of tree and then take cell sap as a feed and then produces uh, lac for us, which can be processed, and many value-added products can be obtained from lac. We can see here that how that these lac, small tiny lac insects are settling on the branches, and then it is producing lac incrustation on the branches of trees, which is a useful material for us. The major lac host plants are Buttia monosperma, Gigifus mauritiana, Siliceria oleosa, known locally as Palas, Kusum and Bear. These are the major lac host plant. Apart from these plants, there are other lac host plants also, on which lac insects settle and produce lac. If we see, we get lac as a incrustation, which can be converted into seed lac, which is a raw material for value-added products like shellac, bleached lac, aluritic acid, and different other products made out of lacs. So if we see the material what farmer is getting contains three useful things for us, that is resin, lac dye and lac wax, and these three important component of stick lac of the farmers produce has got different applications. So some of the processes and product technologies developed at Indian Institute of Natural Resins and Gums, which we are transferring through either licensing or institute regular training program. Uh, Under that category, we have different technologies related to processing of lac. We have developed a small scale lac processing unit, integrated small scale lac processing unit. Although processing of natural this lac is being done in processing industries, but if some farmer or a small entrepreneur want to process the lac at village level, for them we have developed a small scale these processing unit, which can either be operated manually or with the help of a small single phase electric motor, so that it can be uh, unit can be established in rural areas and farmer can process their lac, and in processed form they can store seed lac in metal bin or in gunny bags, so that whenever they get a remunerative price they can sell their produce. Otherwise, just after harvest they have to sell their produce, because storage is a problem. Proper storage requires lot of space, airy space, which is usually not available with the lac growers. And then we have fruit coating formulations. We observe that many fruits like apple, oranges, kinnus, etc. are coming in coated form, even pomegranate, to increase the shelf life and its appearance. And there are many formulations, and there are lag based formulation also which can be utilized. Other formulations which are being used in market in nowadays are synthetic formulations, and as we know that synthetic formulations or chemical formulations are not very safe for human health. So we can have fruit coating formulation based on lag, which is possible for coating of fruits, vegetables and spices, so that the shelf life and appearance and its value are enhanced. Then we have varnishes for wooden surfaces. Then we have varnishes for uh, all the surfaces, that is lag place, which can be applied on metal surfaces, wooden surfaces, and even in on handicraft items, so that appearance of the items are improved and their life also improves. Then we have also uh, air drying and baking type insulating varnish, what is used for coating of the bindings of motors and generators. And we have also developed at this institute aqueous lag varnishes for earthenwares and bamboo based articles. Then shellac emulsion paint has also been developed for coating of internal surfaces. Then there are some products which have been developed, like lac-based nail polish, lac-based natural alta, then shellac-based dental plate, shellac gasket compound, process for making bleached lac. As we know that lac has got brownish in color, as we have seen in earlier photographs. So for coating of say fruits, vegetables or teak furnitures, etc., people prefer transparent varnish. So we bleach the lac, we remove the color of the lac by bleaching action, and we produce bleached lac. And for that also we have technology which is transferred to the interested entrepreneurs. Then we have dewaxed decolorized lac. Again, the color of lac is removed and wax present in lac is removed here, so that it can be utilized for pharmaceutical applications or food applications. Then another important component which we obtain from lac is aluritic acid, which is utilized for preparation of isoambrotolite, which acts as a fixative for perfumes. Then another important is lac dye, which is utilized for coloring of animal fibers, particularly silk and wool. And it is also in some countries like Japan, China, uh, these color, that is lac dye, is permitted for application in food as a coloring materials. Then we have also other technologies related to natural resins and gums, which we transfer either on licensing basis or through our technical uh, training programs. So these are different products which gives entrepreneurship opportunities for having a small scale industries established and earned good uh, uh, income by establishing those units. So some of the examples we will see. These are some of the photographs of different technologies and product developed at the institute, which are being transferred to entrepreneurs or interested uh, industries for their production and sale. So if we see the lag processing technology, what I was discussing earlier, we have developed four machines which can convert this stick lag into seed lag, which is a raw material for making value-added products. So if we see the economics, the unit capacity is 100 kg per day. It means 100 kg stick lag can be processed in one day, and it gives employment of about 750 man days per year. And once this unit is established, in initial year one can earn around 0.25 lakh per month, and in after payment of loans etc., they can earn up to 0.5 lakh per month by establishing this unit. At the same time, it gives employment opportunity for 750 man days. And then there is another unit developed, that is integrated small scale lag processing unit. In earlier unit, we saw that there are 4 different machines, but here all 4 different machines have been combined into one to reduce the labor requirement. And we can see here that by having such type of unit, again 100 kg of stick lag can be converted into seed lag, and one can earn up to 35,000 rupees per month in initial years, and more in later years after payment of loans etc. And this also unit gives opportunity of employment generation in the rural areas. Then there are some lag based value added products and byproducts which can act as a entrepreneurship development opportunities. And one of them is making bleached lag from seed lag. We can make bleached lag by having pilot plant of bleached lag, for which we impart training at our institute, and we also support the entrepreneur who are interested in establishing such units. And here we can see the economics of the unit. A 50 kg per day capacity unit can be installed at an expenditure of around 20 lakh. And once it is established in initial year, one can earn 0.5 lakh rupees per month. At the same time, it generates employment opportunity for 600 man days per year. And in later years, after payment of loans etc., one can earn up to 1 lakh rupees per month by establishing this bleached lag plant. Then there is another technology, that is dewax decolorized lag. For that also we have a technology, and one can earn more than 60,000 rupees per month by establishing the pilot or plant for making dewax decolorized lag. Then another important, that is very valuable component which can be extracted from seed lag, that is known as alluritic acid, and which acts as a base material for making isoambrotolite, which acts as a fixative for perfumes. So if this unit of 25 kg per day capacity is established at the cost of around 23 lakhs, then one can earn in initial year 0.75 lakh per month, and in later years up to 1.5 lakh per month. And this also gives employment opportunity of 750 man days per year. Then this is isoambrotolite, which can be made from the alluritic acid. For this also we are having technologies and imparting training for those who are interested in establishing isoambrotolite unit. And few of the industries have taken training from our institute and has established their industry for production of isoambrotolite, and they are exporting in countries like France and Germany. Then the byproduct we are getting from lag processing industry, that is one important byproduct is lag dye, which we get from wash water of lag processing industry. And this dye is again very important, which can be used for coloring of animal fibers, and even it can be used for coloring the food items. And we have a technology at this institute for making 1 kg per day capacity lac dye. This appears very small, but its cost is very high. And for establishing such lac dye plant, budget of around 13 lakh is required. And once it is established, one can earn 0.4 lakh per month. And at the same time, it gives employment opportunity for 450 man days per year. So, like this, we can see that by different products, what we can make from lac gives very good entrepreneurship opportunity or employment opportunity once those units are established for production of value-added products. So these are some of the applications shown in this slide of lac dye. We can see here for dyeing animal fiber like wool and silk it is used, and it is also used for coloring the food items. Now coming to some important gums of India. The topmost gum which is produced in large quantity in our country, and India is leader in production of guar. So annually India is producing about 8.5 lakh tons of guar seed, and as we have seen earlier that around 2.8 lakh tons of natural resins and gums are being exported from our country, and major quantity is coming from guar. We can see here that these are the guar tree plants, and from that we get the guar seed. And once we get guar seed, first of all it is converted into its split, that is that which contains guar gum. And once it is converted into powder form, it is known as guar gum, which is utilized for different applications. In production of guar, India is leader, and it is also produced by Pakistan, Sudan, and USA in a small quantity. And contribution of guar production coming from India is about 80% out of the total production in our country. So coming to some important exudate gums of India. Under this category, gum arabic, which is coming from Acacia senegal tree, is one, for which there is a large potential in state of Rajasthan, Gujarat, and Haryana, because dry land and barren lands are there in very large areas, and climatic condition in these states are suitable for growing Acacia senegal tree, which can become a good source of income for local people. At the same time, we have seen in import-export data that India is importing large quantity of Acacia senegal gum from African countries like Sudan, Kenya, and other countries producing Acacia senegal gum, that is Arabic gum in Africa. So we have a large area in these dry states like Rajasthan, Gujarat, and Haryana, where this tree can be introduced, and we can produce a large quantity of Acacia senegal gum to meet our internal consumption, which is used in food industry, pharmaceutical industry, textile industry, and chemical industries. And once we start producing in large quantity, we can become a leader in production of this. We can also export, and which can also give us opportunity to develop value-added product out of these gums so that it generates employment opportunity as well as entrepreneurship opportunity in our country. Then this is another important gum karaya, mainly produced in states of Andhra Pradesh, Chhattisgarh, Madhya Pradesh, Maharashtra. And this is a gum having unique feature that it doesn't dissolve fully in water. It dissolves partially and it makes very viscous solution in water. And its annual production is around 1,500 metric ton. And due to more internal demand in nowadays, rather than exporting, we are importing also this gum from other countries. But there is a scope of having these trees in forest area in states of Andhra Pradesh, Chhattisgarh, Madhya Pradesh, Jharkhand, Odisha, so that we can increase production of gum karaya. Then important gum resin in this category, Essa foetida, what we call hing in our local language, is utilized in different food items. This particular product we are producing in hilly states like Himachal Pradesh, Jammu and Kashmir, and Uttarakhand in a small quantity. But we are importing in large quantity from countries like Iran, Iraq, Afghanistan, and value addition is taking place in our country, and then we are exporting it. And this particular commodity, as we know that it is used in different food items and also in alternative medicine and Unani medicines. So if we see the role of natural resins and gums in national economy and livelihood support, natural resins and gums export is of worth more than 3,000 crore rupees per annum, and it gives support to 50 to 60,000, 60 million population inhabiting forest area, sub forest area, in desert, in coastal areas. And this gives also a source of employment in forest area for gum, resin, and other MFP tapping and collection work. So we can see this sector has got good potential for economy as well as for livelihood support in forest and sub-forest area, in a disadvantaged area, or in other words also we can say in some disturbed area, this can also become a livelihood support so that those disturbances are reduced. Then considering the importance of this sector, what are research support to this sector, we will know. Indian Institute of Natural Resins and Gums with mandate on research on lag production technologies, processing and value addition of natural resins and gums is a research support to this sector coming through ICR from Government of India. Then there is a one network project with 5 objectives, and this network project is also working for research support for this particular sector, and it is having 10 center for different resins and gums spread in different parts of the country. So these are 10 centers we can see for different gums like gum arabic, agroforestry model development based on gum and resin trees for rosin, guar gum, Google, Karaya gum, tamarind seed gum, Damar, and Pinus cassia. For these, we have different centers located at different, either in ICR Institute or agricultural universities. So this we can see the spread of network project center in different part of our country. At international level, there is a network for natural gums and resins in Africa, and there are 14 countries associated with this network, mainly sub-Saharan countries. And again, the goals and missions and objectives of this network is similar to the network we have in our country. So these are some of the objectives of the network in Africa on natural resins and gums. So if we see in a summary that this particular sector has got different applications in food, pharmaceuticals, cosmetic, textile industry, paper industry, even in newer applications like nanoparticles, etc. These are also finding applications. But at the same time, this sector is facing some challenges like decline in production, then unstable supply, and then over exploitation of the trees which is producing these natural resins and gums. And due to over exploitation, we are losing these precious trees. So this sector also gives us opportunity apart from the challenges. This is a unique natural food material, and increase of demand of natural resins and gums we are observing being a natural project, and our inclination to natural projects compared with the synthetic ones. At the same time, this sector is also providing livelihood support in forest areas coastal areas, in desert areas. So these are the opportunities of this sector. So with this, I would like to conclude my talk. I wanted to share some of the informations related to natural resins and gum sectors, and what opportunity it can provide for entrepreneurship development in climate generation, and about this sector. So thank you very much. If anyone interested to have further information on this sector, they can contact us on the given email address and mobile number. So thank you one and all. If there is any query or clarification, I will be happy to answer them. Over to Dr. Pathak.
Thank you, Dr. Niranjan. डॉक्टर निरंजन, बहुत अच्छा और बहुत ही इंफॉर्मेशन आपने दिया हम लोगों को। मैं थोड़ा सा एक दो क्वेश्चन आपसे पूछना चाह रहा हूँ।
Yes.
और वो हमारा रिलेटेड होगा फॉडर से भी। देखिए, जो व्हीट एक्स्ट्रा होता है उसमें बाइंडिंग प्रॉपर्टी नहीं होती है, जैसे उसको कंप्रेस करते हैं तो स्वेल हो जाता है। तो प्रॉब्लम किसानों को ये होती है कि वो जब ट्रांसपोर्ट करते हैं या स्टोर करते हैं तो बहुत एरिया लेता है और लूज होने के कारण इजी नहीं है। हम लोगों की कुछ स्टडी है कि कुछ बाइंडिंग मटेरियल ऐड करके, जैसे मोलासिस है या कुछ और आपने गम्स बताए, उसमें कर सकते हैं। तो क्या आप लोगों ने कभी इस तरीके की स्टडी की है कि इस तरीके से हम व्हीट भूसा वगैरह को बाइंड कर पाए?
Frankly speaking, to my knowledge, we have not done any study on binding as a binding agent in form of natural resins and gums for compacting the fodder or feed. But certainly it has been utilized in making a particle board as a binder. So
Yes.
I think it should work, and there is a scope of trying your idea, and I am hopeful for that.
सर, मुझे लगता है कि इसमें कुछ नॉन एडिबल भी रेजिन्स या गम्स होते होंगे, और जो एडिबल गम्स होते होंगे उनको यूटिलाइज करते हुए हम क्या एक कोलैबोरेटिव प्रोजेक्ट स्टार्ट कर सकते हैं IGFRI के साथ, जिसमें एंटरप्रेन्योरशिप का भी स्कोप हो?
Definitely, sir, but I am not the final authority to say yes, but I will support from my side, and the two directors can interact and they can decide.
यस सर्टेनली, ये जरूरी है कि दोनों डायरेक्टर ही डिसाइड करेंगे। लेकिन सर इस अभी जैसे मेरे पास लेक्चर स्टार्ट होने के पहले अभी एक किसान का फोन आया था, वो बिहार से था। मैं बोला कि आप अभी हमारा लेक्चर सीरीज स्टार्ट हुआ है, आप उसके साथ जुड़िए। वो भी शायद ज्वाइन किए होंगे, तो वो चाह रहे थे कि फॉडर में कुछ इंटरप्रेन्योरशिप करें। तो हमने उनको सजेस्ट किया कि साइलेज कर सकते हैं या व्हीट स्ट्रा बाइंडिंग वगैरह का। तो मुझे लगता है उनके लिए ये इंटरप्रेन्योरशिप जो आपका रांची और बिहार पास पास में, ये ज्यादा अपॉर्चुनिटी बैठ सकती है। इसके अलावा कर्नाटका से सर फोन आया था अभी, और वो भी शायद ज्वाइन किए होंगे। तो मुझे लगता है कि रेजिन्स में स्कोप बहुत ज्यादा है। मैं इनवाइट करता हूँ डॉक्टर सुनील तिवारी, दिख रहे हैं, उनके कुछ कमेंट्स के लिए। डॉक्टर सुनील तिवारी
Yes,
क्रॉप
yes.
प्रोडक्शन डिवीजन के विभागाध्यक्ष हैं। आपका सर वैल्यूएबल कमेंट।
Thank you, Dr. Pathak and Dr. Prasad. You have shared very informative knowledge, and it was very interesting topic, at least for us, because we are dealing with different kind of commodity here. But my question is that the basic question nowadays, you see, we are talking of doubling the farmers' income, raising their income, their farm income, improving their livelihood, reducing their cost, and retaining youth in the agriculture. So I could see a lot of scope, at least in the states where government raising could be a very good venture to take it up, particularly in Jharkhand, MP, West Bengal, and Chhattisgarh like states. Whether your technology or your institute or your network partners have collaborated with some of the KVKs who are working at the ground level at every district. Their programs are there, and almost all aspects of agriculture, horticulture, and animal husbandry and related aspects are being dealt by those centers. So some of the success story are commercial modules, or ventures, or entrepreneurship models in those states have been taken up by the KVKs to promote among the farmers.
Thank you very much, Dr. Tiwari. As you have rightly pointed out, there is a need to utilize the vast network of KVKs in transferring technologies being developed by ICR Institute. And you have rightly pointed out, and we are also taking help of KVKs in terms of whenever we are required to reach to people in tribal areas for popularizing natural resins and gums production as well as primary processing. We are taking help of KVKs in states of Chhattisgarh, Madhya Pradesh, and Odisha, West Bengal, and in southern states like Karnataka, lot of KVKs has initiated to try our technology of coating formulations like vegetable coating, fruit coating in states of uh, Tamil Nadu and Karnataka, and we have supplied them the material, coating material, and they have tried, and they have reported good response, so that the shelf life of vegetables and fruits are increased. So these are some of the collaboration with our KVKs for production as well as for primary processing and value addition aspect of the some of the technologies developed at ICR Institute, and we are continuously in a process of roping in more and more KVKs to transfer these technologies to the end users. Not only KVKs, we are directly also interacting and having relationship with industries, which are another important partner in natural resins and gums sectors, and almost every year we are organizing industry meet in which industry from different natural resins and gums sector, we are inviting them. Even we are moving out. We organize industry meet at Jodhpur for say Guargam Industries. We organized industry meet at Mumbai. We organized industry meet at Hyderabad, Visakhapatnam, and in state like West Bengal in Balrampur, where there are a lot of lag processing industries. So that is how technology is being developed by our institute in collaboration with KVKs and the industries. We are popularizing them and trying to transfer
Yeah,
them.
thank you very much. That was a very nice information I could get. But one thing that in eastern region, KVK particularly in West Bengal, Odisha, and Jharkhand, and maybe part of Bihar also, what is the prospects for LAC? Suppose we want to promote LAC through KVKs and to have a model, a successful model, commercial model. What is your opinion on that?
Uh, uh, Very good question. Actually, lag production earlier or even in nowadays taking mostly on tree-based system. That is major lag host trees are Kusum, Palas and Bear. But our institute has identified one bushy lag host plant that is known as Flamingia semellata, and it can be raised in 1 year, and after 1.5 year farmer can take a harvest. Otherwise, if plantation of say kusum or palas or bear is grown, then it takes lot of time to get plant to have lag for lag insect for lag production. So bushy lag host plant is being popularized, and it has gone in a vast way, and say in a span of 7-8 years, more than 1,000 hectare has come under plantation of Flamingia semellata for production of lag, and this particular bushy lag host plant can be popularized in states as you have told, in say eastern states like Bihar, Jharkhand, West Bengal, Odisha, even in Chhattisgarh and Madhya Pradesh it is getting popularized.
Okay, thank you very much. Thank you.
Welcome. Any
Dr.
other
Pathak.
query or clarification?
Dr. Pathak, organizers, please see.
Any
हेलो
any
हाँ, यदि किसी को प्रश्न पूछना है, यहाँ पर बहुत विद्यार्थी जुड़े हैं, बहुत से वैज्ञानिक जुड़े हुए हैं इस लेक्चर सीरीज में। यदि किसी को प्रश्न पूछना है तो वो पूछ सकते हैं। हमारे साथ कुछ एंटरप्रेन्योरशिप भी हैं, तो यदि आप पूछना चाहें प्रश्न तो कृपया पूछें डॉक्टर निरंजन प्रसाद से डायरेक्टली।
Sir, I have one question.
हाँ जी।
Sir, can you tell me about the this impact of your coating product which you are using for the vegetable and fruits coating? So, how much shelf life can be enhanced through using this coating material?
It depends upon different vegetables and fruits. Right from say 1 week to 2 weeks, we can increase the shelf life.
So, is it edible one or it's a non-edible?
It is edible.
Okay. That can be used for any fruits and vegetable or a specific one, sir?
Wherever coating is likely to enhance the shelf life and the quality or appearance of fruits and vegetables, and where it becomes economical for coating, there only we can apply, like say costly vegetables in say off season capsicum may be there for
So
such,
it is,
or even fruits like say apple, oranges, or kinnu, or pomegranate.
so it is means it's not crop specific. One can use for any crops and means any fruits and vegetable.
Maybe slight variation may be there in formulation.
Okay, okay. And what is the cost of, sir, per unit cost of your product?
Per unit cost, it will not be per unit. We can say in per liter, which will be utilized for say a few quintals of vegetables, and so exact price I do not know, but it will be around say 500-600 rupees per liter,
Thank you, sir.
which
Thank you.
can coat several quintals of fruits and vegetables.
Okay, okay. Thank you, sir.
Any other question? Participants, students, or entrepreneurs? If not, then with permission of our expert, we will close this session. Dr. Niranjan, can we close?
Yes, sir. Before that, I would like to thank Director IGFRI and Dr. Pathak for giving me opportunity to share my views on natural resins and gums to distinguished participants of today's lecture. Thank you very much. And as I have given in last slide my contact details, in case of any further information desired from our side, we will be happy to share with them.
Sir, एक information आई है. Dr. Siraj, who has written that natural resins and gums have great scope for entrepreneurs. B, it lack guar gum, other resins and gums lack being mostly produced from trees. The space down the trees can be used for fodder production. So I think very good information as given by Siraj, and agroforestry model can be utilized for production of fodder as well as this gums and resins. And one more thing, using edible gum as a binding agent for fodder may increase cost, which may not be economical. Gum are expensive proportion for fodder. What is your opinion, sir, Dr. Niranjan?
Different gums have got different prices. Say, for example, exudate gum, if we consider, mostly it is costly and it is also produced in small quantities. But if we consider, say, guar gum, tamarind seed gum, cassia tora gum, those gums are not very costly. And if we are able to develop formulation out of these seed-based gum, it won't be very costly affair, I think.
Sir, we have used guar gum waste for binding our wheat visa. So I think that could be an opportunity.
Yes, sir. And it is not very costly.
Yes, that is not costly. We purchased from Jodhpur.
Yes.
Okay, sir. With these remarks, I invite Dr. Deepak Upadhyay for formal vote of thanks. Dr. Deepak. Deepak.
हेलो हेलो
हाँ जी, दीपक
हेलो
प्लीज.
Yes, sir.
हाँ, आवाज आ रही है.
Yes,
हेलो
आवाज आ रही है.
you are audible, sir. Deepak, sir, you are audible.
I think he is audible, but he cannot listen to us.
Just call in.
Amit, I think if he cannot listen, you only present the
Okay.
vote of thanks to all.
Okay, sir. Thank you, sir. I would like to thank Dr. Niranjan Prasad, sir, for delivering a wonderful lecture on entrepreneurship potential and opportunities in natural resins and gums for startups. And sir, you have given very important information regarding these resins and gums and their byproducts, and also you have told good machineries for processing of these resins and gums. So this will be very much beneficial for the entrepreneurs who have joined us today. So thank you, sir, for joining us today. And I would also like to thank all the participants who have joined this lecture today, and also the office bearers of Indian Society of Agricultural Engineers, New Delhi, and Range Management Society of India, Jhansi. So thank you very much to all of you for joining us, and thank you, sir. Sir,
Thank you.
हाँ जी सर, कोई कुछ पूछ रहा है?
नहीं.
Okay, then we are closing, sir. Thank you.
Thank you. Thank you very